Hello, hello. Am I audible? Hello. Yeah, I think I'm audible. I'll share my screen in a few minutes. Yeah. Hello. My screen is visible, right? Hello. Yes.
Yes, sir.
Okay. Happy Independence Day, everyone. So start today's lecture. Tutorial session of week 4 of calculus of real variable. This is Rahuldev Ghorai from School of Mathematics, Science, Thiruvananthapuram. So this week's topics were Newton's method for solving differential equations. Sorry, this will be equations using iterative numerical methods for finding the root of the equation mainly. And then optimization problem, mainly the minima maxima, which we saw also already, and in the integration, mainly this three type of integration. We'll mainly be solving in today's class. We'll be solving few questions. Most of them are related to your assignments. So if you have any question before that, I can discuss those. Otherwise, we will I move to the question answer session, because like tomorrow's class I have preponed to this today's class, I mean Friday, due to some work I have, and yeah, so we'll be solving few questions from this week's questions. Okay. Okay. So let's assume that you don't have any question. Maybe I mean, maybe you will have it later or something. We'll start with like Newton's method. The question from Newton's method. Okay. Let's say. Fx is equal to x, x square minus x. and x naught, the initial guess, is -1. Then what is the value of x2? Okay, so anyway, am I audible? I think wherever I am, it's raining a lot. So is it okay? Can you? Hello. I hope I'm audible. Okay, I'll just continue. So what to do that? So you know how to evaluate that. So that is xn plus 1 is equal to xn minus f of xn over f prime xn. This is the iterative scheme. Mean x1 will be equal to x0 minus f of x0 over f dash x0, right? And what is x0 given to you is -1, and minus what is f of x0 means, okay, so let's write f of x0. F of x0 will be -1 whole square minus of -1, that is 2, right? So in this case it will be 2 over what will be f prime. F prime is 2x minus 1, right? So minus 3, 2x minus 1, 2 minus 2 minus 1. So that is uh, 2 over 3, right? 2 over 3 minus 1 equal to minus 1 over 3. Now once you got x1, what will be x2? X2 will be x1 minus f of x1 over f prime x1. What is that? X1 is 1 by, sorry, negative of 1 by 3 minus f of x1. What is f of x1? It will be 1 by 3 whole square plus 1 by 3 over 2x plus 1 means minus 2 by 3 plus 1, right? That implies minus 1 by 3 minus 1 by 9 plus 1 by 3 over 1 by 3, right? So that is equal to minus 1 by 3 minus 1 by 3 plus 1, equal to minus 2 by 3 minus 5 equal to minus 5 over 3. Okay, something I am getting like this. I don't know, it's something. Do you understand how it will become me?
Yes, I think the derivative is 2x minus 1.
Yeah, this is 2x minus 1. Yeah, so some one, only one places you have to change it. That is 2x. Yeah, that is always 2x minus 1, right? I mean, just say minus 1 here. Okay, yeah, yeah, yeah. Great, great. That is 2x minus 1 always. So this is 5 over 3, right? This will be 5 over 3. Uh, Minus 5 over 3. So it will be also then positive, right? So 1 by 3, it will be 1 by 3. F prime x. So f of x naught is 2, and f prime x naught will be minus 1 and minus 2 minus 1. Yeah, that is okay. So total it will be minus 3, right? So that gives you 2 by 3, that implies minus 1 by 3. So this is okay. So now when it comes here, it will be negative minus 2 minus 5 by 3. Okay, this is minus 5 by 3. Yeah, it's now coming maybe. So minus 5 by 3. Yeah, so whatever the calculation here, that will be changed now. So that's all. Okay, let me do it once. uh, that will be minus 1 by 3 plus 1 by 5, 1 by 3 plus 1, right? That will be 4 over 15 minus 1 over 3, that will be minus 1 over 15. Yeah, that should be the correct answer, right? That's what you got. You were trying, you are trying, you should get this minus 1 over 15.
Yes.
Yeah, so that will be the correct answer. So you need to only find here up to x2. So like that. So some type of questions like this you may get. So, and I'll move to the next question, which I think he has done already in the class. So okay, I'll find another question. Okay, so let's try to find. You know what is convex function, right? Convex function definition, you know?
Yes.
Yes. Uh, can you say whether this is convex or not? Okay, OW means otherwise. Okay, means otherwise. That notation I use. Otherwise, how the function will be? Can you draw the function? Function, if you draw, this will be when minus 1 to 1. It follows this type of. This is x-axis. The symmetry will be symmetricity will be there, right? Then it will be, otherwise it is 1. That's the function. Now whether this function is a convex function or not.
Yes, it is.
Is convex function?
Yes.
Other? Yeah, this should be convex function. I think it was not a difficult question. Yeah. Okay, what about this function? Fx is equal to y minus whole to the power 4 plus y to the power 4 plus y square minus 12y minus 15.
Yes, it is also a convex function
How?
because f double dash y is greater than equal to 0.
Oh, you could prove that. You
Yes.
have proved that.
Yes.
Okay, so that is good. So if you have a differentiable function, then f double prime x is, if it is greater than equal to 0. So first of all, it has to be differentiable, and then if double prime x. So what you got, that f double prime x
12 into y minus 1 squared
12 into y minus 1 square
plus 12y squared plus 2.
plus.
12y squared plus 2.
Okay, so that's, if you're getting like this, so you should get something like this. It's not, most probably it will be correct. So something which is, okay, x not y, is greater than which will be always greater than equal to for all x, right? So that implies uh, f double prime x is greater than equal to, f is differentiable and f double prime x greater than equal to 0, then what you will get is f is convex. So something you can write like this: if you have fy from the Taylor expansion, what you can write, fx plus, if I'm not wrong, then y minus x times f prime x plus y minus x whole square over 2 f double prime some xi x, right? Something between this. So then, if this is greater than equal to 0 and this y minus x whole square greater than 0, what you get, fy is greater than equal to fx plus y minus x f prime x. So, I mean, what you will get is, if y is of course greater than x, if you have to assume, then fy minus fx over y minus x would be greater than equal to f prime x. So this is something says, right? So if you have, uh, let's say this is x and this is y point, uh, something you can say from here. So y minus x over this one is nothing but this slope. I mean this slope of this tangent, slope of this line, f of s, is that has to be always less than equal to f prime x. F prime x is the tangent at the point x, right? But yeah, okay, I just wanted to show you that whether that convexity you can follow from here just by saying this. So that is, I think it needs some more things to show that if we, from double prime dash is greater than equal to 0, can you show that it is like this definition? You can, either you can come f t x plus 1 minus t uh, y, that is less than equal to t fx plus 1 minus t fy. Okay, so that also you can show, but not maybe from here, so you can leave it that. Okay. Okay, so now we come to ap graph. What will be the ap graph of this fx equal to x minus 1 whole square? Question. Ap graph of f. So that is usually epigraph of f is defined like all those xy, right, belongs to R2 such that fx has to be less than equal to y, right? Then in this case, ap of this function capital F is will be xy belongs to R2 such that x minus 1 whole square has to be less than equal to y. But you see, x minus 1 whole square is positive number, guys. So it cannot be less than equal to y, which is negative. So what we will do, xy belongs to R2 such that this set is nothing but equal to less than equal to y, where y is greater than equal to 0. These two sets are equal because y negative, it is this set will be 5, and xy now belongs to R2 such that what you can write, x plus 1 less than equal to square root y greater than equal to minus of square root y, where y is greater than equal to 0. Mainly xy, all those xy which are in R2 such that x less than equal to square root y minus 1 and minus 1 minus square root y, and where y is greater than equal to 0. That will be the epigraph of function. So using epigraph, people can find some other properties maybe. Uh, so that's why that is important here. Okay, so one more question. Okay, so this one is also easy, but let's do. Okay, what about this function? X cube minus 3x square plus 5. So that is also easy. So you can see that first it is, so you don't need to show that this theta x plus 1 minus theta y, that will be very difficult, right? That is less than equal to this thing, that will be difficult. So what you do, use the thing that it is differentiable function, and also f double prime x is greater than equal to 0 in the domain 1 to infinity. 1 to infinity. So this function is will be uh, convex function over the domain 1 to infinity. Okay, something more I just wanted to give you. Differential function.
I think it should be 2 to infinity.
Are you sure? Uh,
Yes, because f dash 1 is negative.
yeah. Let me check it, this question.
But
Okay, so f dash x is equal to 3x square minus 6x, right? F double prime x will be 6x. Yes, minus
oh,
6.
sorry, I just checked f dash x.
Yeah. If double prime x, you have to check, right? Yeah.
Yes.
Okay, I'll just move to another thing. I mean, the convex function only, but it will be little difficult. That is, I will give you now. Just 1 minute. Wait. Yeah, you know the linear functions are convex functions, right? That is trivially linear functions are convex functions. That is okay. And you know the local minima or global minimum, any local minimum. Knowing all these things, okay. Something is there which I would like to say. This rank is not convex. What is the meaning of that? So in people can anyone can give rank of a matrix as can be interpreted as a function, right? From here to here. So rank it is a name. Let's say you can n cross n cross n matrix will have a rank. So do you know about rank or no? Rank of
Uh, I don't know.
okay. Then leave it. Sorry. So vector space, all these things you don't know.
No, I'm in first year.
Okay. I'll just erase this part. I just wanted to tell you. I thought you might know. Leave it. No problem at all. So, and to give you some functions, little difficult functions which are not complex function. Okay. I think that is not the case. Okay, then let's move to the integrability mainly. That is the thing only we left. But there will be many more things in the integrability. Let's say you have this function fx 1 minus x, and the partition is given like 0, 1, 2, and n minus 1 by n and 1, which is the partition of 0 to 1. All of these things you know, I guess. Then what is UPF? UFP. You know, UFP is the upper sum, right? How do you define that upper sum?
No, I think this is not thought.
Sorry? Yeah,
This is
this is
not
short.
covered.
This is not hard.
I think in week 4 it is not there.
Yeah, it is there. I'm taking for U4 only, right? It's a integration rule is there, right? From Newton's method, then integration, right? No?
Yes.
Yeah, so that's why.
But this notation and all is not covered. I don't know what it means.
UFP means the upper sum, right? Okay. So that for you have a function f, and you just take sum over f of for the upper sum, it has to be the maximum between this f of x. I'll tell you this. Let's say I is equal to 1 to n, and n has to vary, so that has to be supremum. But okay, 1 minute. So this is xi minus xi minus 1. Let's say you have a partition from 0 to n. I mean, you have, let's say, partition p is equal to x0 and up to xn of an interval. And then fx for u, it has to be fx is the uh, f x star, let's say x star, which has to be the x star is the maximum in the interval xi minus 1 to xi. I think notation he's like notation maybe he did not tell, but he did told about upper sum and lower sum. I went through the video, right? I watched the video. He was telling something upper.
Yes, but very less is covered, I think.
Okay, but questions may come from here. So assignment your I was checking your previous previously they gave some assignment. Okay, previously mean the last semester when this course was rerunning, this question was there. So I thought of let's put it. It's not like I am just making it. Huh? So they only gave this type of question. So this is the just notation. UPF U means upper sum. Okay, U that sense upper sum, and you just remember that Fx star for the upper sum it will be uh, xi minus 1, and x star will be the f of x star will be the value of the function f, maximum value of the function f in this domain. If you have a lower of p fp, that will be the minimum value in this domain f of x star times xi minus 1. That's the summation. which this question is there, so that's why I just asked. So now can you just find it out with how to find out for this simple function? This is easy. And your function integrability will be if a to b fx dx, this function integrability will depend on whether this upf, you have ufp, ufp, and you have lfp, right? So you take infimum of all those ufp over the partition and it is supremum over p. If they are equal, then this will, that value, whatever the value, that will be equal to this integration value. If they are not equal, then this will not be, this function will not be integrable. So integrability of the function can be determined using these two things, this UPF and LPF. So if you
I
are not
think
understand,
integrability is not covered.
so what he was doing in this, what he did in this three integration thing, I mean like
He
this
just gave
integration,
some geometric intuition about integration.
geometric integration.
Nothing rigorous was done.
Okay, okay, but that might be
He
coming
said
in the.
real integration will be covered in week 5.
Oh, but the question is, see, this type of question is there, so I was thinking that's why to do these things, because questions was there in the previous uh, assignment. So now this assignment, how then questions are there? What type of questions can you tell them? This assignment,
This assignment, Newton's method and all is there.
only Newton's method.
Wait, let me check.
Yeah. So then we can do those things, because whatever assignment of questions I have like this only.
Oh, okay.
No, no, but you can tell me your whatever the assignment you got for this week.
Yes. Uh, to find antiderivative of function and some differential equation.
Sorry.
Like f of x is equal to root x plus 1 by root x is given. We have to find its antiderivative.
Root x plus 1 by,
Root x.
like this. I have written right.
Wait, let me check. Yes.
Yeah.
Then
Then
one question is, other question is dy by dx is 2x minus 7 and y of 2 is 0. What is y of 2? y.
Wait. Let me write it. Dy dx, then dy dx.
It's 2x minus 7
2x minus 7.
and y of 2 is 0.
Y of 2 is 0. Okay. What are
Then
these?
what is y?
But what about this? I mean, what is this? I don't understand. So fx, why fx?
We have to find its antiderivative.
Centered derivative.
Antiderivative.
Antiderivative.
Indefinite integration.
Yes. But dy dx y2, I don't understand.
This is other problem.
Oh, okay. This is one problem, and this is another problem. Okay. So antiderivative of
Yes.
fx. So you have, I mean, like that, right? So dy dx equal to some g function, right? G of x, and then gx will be integration over
Yes.
fx, right? That's all.
Yes.
But those are easy, okay?
Yes.
That you can do, right? So that is
Very.
square root x plus
Yes.
1 over square root x. Dx will be, of course, dx will be there. So that implies x to the power 3 over 2 over 3 over 2 plus x to the power half over half. Is not it?
Yes. Assignment I have done. It's very easy. There is no problem in it.
Exactly. So that's anyway. And okay, how do you, okay, this question, okay, maybe for other people will be also there. So this question, let's do the second question, maybe after that I move. The second question, what they're asking?
What is y as a function of x?
But why this differential equations are, I mean, in this lecture? So no differential equation solving was there, eh? I mean, I don't understand why
No,
this.
but
Y will be 2x
I don't know.
minus 7 dx plus c, that is equal to x square over 2 minus 7, sorry, 2 times x square minus 2 minus 7x plus c, and y2 is equal to 0 is given to you. So that implies 0 is equal to uh, y at 2 is 0, so 2 square minus 14 plus c, that implies c will be 10, and you then y will be x square minus 7x plus 10, right?
Yes.
I mean, why these type of questions, I don't know. So I saw in the last.
And area
Yes.
problem is there.
Okay, what is that problem you have done?
So yes,
Then leave it. Yeah, tell still. Yeah, tell. That may be another question I will do. Yeah.
y is equal to minus x square minus 2x.
Minus x square minus 2x.
Yes. And we are given x between minus 3 and 2.
Minus 3 and only 2 or minus 2.
Minus 3 to 2.
Okay. Huh.
So we have to find area between this curve and the x-axis.
Okay. Curve will, this you have, and let's say minus x square minus 2 means minus, okay, it will be the negative of all these things, minus x, so it will be 0 and minus x, if you take common, minus 2, at these points it will have 0, this is minus 3, this is 2, right? This is 2. So at minus 2 0, at 0 0, otherwise it will be minus x, let's say x plus 2. If it's bigger than minus x minus 2, it is always positive, right? So minus 3 to minus 2, it will be negative. So this is negative. Okay, minus 2 to 0. Uh, Minus 2 to 0, it will be no, minus 2, not 0, minus 2 to that will be also negative. Let's say minus 1, it will be positive. Okay, so yeah, I mean this is negative and then positive, and this 0 and 0 to 2, it will be so bigger than 0. I think this type of some function will be there, right? So this will be this type of function will be there, right? If I'm not wrong. So minus x square.
Yes.
I'll just check with the demo graph that whether it is correct. Okay, so now we have to find the area, but nothing is there to do, right? I mean, just y dx from minus 3 to 2, just take integration, right?
Yes, but we have to worry about negative and positive values.
No, mainly you do it's like minus 3 to minus 2 and minus 2 to this 0 and 0 to 2, and you take all the sum, just positive sums,
Yes.
right?
And Newton's method problems are there.
Yeah. What does that say?
Uh,
So this one will negative values are also not a problem, right? So negative may come, right? So this in the area. So if that negative value is even minus 20 or something, you just take that will be the positive value, you can just consider in that sense. Otherwise, that negativity may come. What is the problem in this question?
No problem. I have no problem. I have completed all of them.
Okay. So these type of questions were there. Okay, I thought of the integration would be much little harder than this, all these things, because this is the
I
simple
think it will be
integration
covered in week 5.
next week, week
Yes.
5. Okay.
Yes.
Okay, so you have any specific questions? Otherwise, I'll think about some other question and do it maybe. The specific
No
question.
question.
Okay. Let me check it here. I did not understand why this with this week like this type of questions are given. So something I feel odd, so I did not do much.
Integration was not covered like rigorously.
Uh, that might be the question. Okay, so let's do some simple few things. If it's cos x is greater than equal to 1 minus x square by 2. Can you prove this? I mean, using whatever you have done, so, maybe in IVP, differences and all these things. Okay, for all, it's not for all x. X should be uh, belongs to, let's say x belongs to 0 to 5.
Yes, maybe I can try.
Yeah, let's try. This is, I mean, it's not like something outside. This may also come in the exam and all your NPTEL exams. You know Taylor expansion, right? At least
No,
Taylor expansion is not done.
not done.
I mean, it will not be done. But I mean, most probably it will not be done later also. I mean, you have this fx.
Will be done, I think.
Are you sure? Like this differentiation.
It is there in the course.
This differentiation is not done in your course. Only continuity is done.
Differentiation is done, I think. Yes.
Differentiation done, then I think this should be done, and with the differentiation, that is also not done. Okay.
It will be done after integration, I think.
Usually I read or people do it before after and with integration only. This
Mm. Yes, I can prove that inequality.
how?
We can consider fx to be x square by 2 plus cos x minus 1.
X square by 2 minus cos x, sorry, plus cos x minus 1 you're telling, right?
Yes.
Then
And we can compute its derivative.
f prime x, right? Am I correct?
Uh, yes, you are correct.
Yeah, then
Then this is greater than 0 in open interval 0 to pi.
that is how. That is true, but how?
Maybe we can again differentiate.
That is good. F double prime x is equal to 1 minus cos x, which is positive, right? So that's why f prime, no, then, yeah, yeah, f prime x will be greater than equal to f prime 0 if x is greater than 0, right? Because f double prime x is greater than equal to 0, so this will be increasing function f prime x, right? That implies f prime x
Yes.
is greater than equal to f prime 0, and that is nothing but 0. F prime is 0 is 0, because 0 minus sine 0 is 0. So that implies f prime x is greater than 0, and f prime x greater than 0, that does not imply just fx is greater than 0, right? F prime x greater than 0 means fx greater than f0 equal to f0 for all x greater than equal to 0. And what is f0? F0 will be 0, because here, from here you see f0 is equal to 0 square by 2 plus 1 cos 0 is 1 minus 1, that is 0. So that's how you get fx is greater than equal to 0 for all even x greater than equal to 0.
Yes.
Yes, right. Yes, yes, yes. Yeah. So you have seen this f c plus h. minus fc over h, that converts to f prime c as h tends to 0. So can you show
Yes.
that like this? Fc plus h minus fc minus h over h 2h, that also converts to f prime c. I think it's easy. Just
Maybe add plus h minus h.
okay, then
Let me try.
yes.
Yes, we can add f of c and minus f of c.
Yes,
Then we can split it.
exactly. So fc plus h minus f of c over h, half times h, plus half times fc minus f of c minus h over h, right? So if it's
Yes.
given to you if differentiable function, so this will also converts to f prime c, and this will also converts to f prime c, and total will be half time f prime c, half time f prime c. So both will add. If you add it, this will be f prime c. So I mean by seeing here, what you can see, fc plus h minus fc over h. If function is differentiable, that will converts to also f prime c, and fc minus fc minus h as h tends to 0 over h as h tends to 0, both all are as h tends to 0. Okay, it will also converts to f prime c, even fc plus h minus fc minus h over h will converge to f prime c. But something interesting is there among them. They too are much slower than this. So you will see it later maybe. But for now, you just understand this one. All three of them are. I mean, you have mainly what you are doing. You have a c function, a point, and then you have c plus h, and you have c minus h. So first you can consider c and c with c and c plus h. Also consider c and c minus h, 2 points only. Also you can consider only c plus h and c plus c minus h and c plus h. Then also it will approximate. This is converging to f prime c means they approximate f prime c as h tends to 0. So this type of, it's a centered type of approximation. They and other two are like forward backward type of approximation, because this is c plus h minus c means as you have, let's see, a forward approximation you are taking, otherwise it's a backward approximation, fc minus fc minus h. So those are related mainly. Okay, that's why I just wanted to tell you.
Yes.
Yeah. So okay, I'll another good question was there. Differentiation is done, right? That's what I you told.
Yes, it is done.
Differentiation is done. Okay. Okay. Let's say you have fx is equal to 0 if x is irrational, not that Dirichlet function. Okay, 1 over q if x is equal to this. If I am not wrong, then it is a Thomai function, something called Thomai, where p belongs to z, q belongs to n, gcd of pq is equal to 1. So what about the differentiability of this function? Or I will say, I'll be specific so that f is not differentiable at x equal to 0.
I think I roughly got it, but I'm not sure.
Yeah, that's what roughly is okay. We can discuss. Huh? Roughly is you not to do rigorously. You can do write it rigorously. That will be better for you. But you can tell me the what you want to do, what you are thinking.
Okay, we can write definition of derivative.
Okay, what is that? F of let's say x plus h. Oh, sorry, 0 plus h, right?
Yes.
Minus f of 0 over h minus 0. That is f h over h. That's all. Yes.
F of 0 is 1, I think.
F of 0 is 1.
Yes.
No, 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 sorry, 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 sorry. Yeah, yeah, sorry for that mistake. Here also f0 is equal to 0. Okay, okay, f0 is equal to 0 also. Hmm? P belongs to z because you cannot, otherwise you cannot define this, right? How do you can it can be the function is not defined, okay? Otherwise,
No, it is
how?
defined because
No, no,
0
it
is
is not.
equal to 0 by 1.
No, it is also equal to 0 by 2.
But GCD of 0 and 2 is 2. But GCD of 0 and 1 is 1.
GCD of sorry, GCD of 0 and 2. Okay, so that case also. Okay, let's okay, we check with the questions. It is given like this: 0 P belongs to Z, Q belongs to N. Okay, so let's define the 0 by f0 is equal to 0. So if it is not, let's say, let's forget now. Let's say not, it is not there and it is in 1, right? So then what you are doing? Let's assume that it would have been much better if you are we are taking f0 equal to 0, but let's say not, it's not. Let's do it
Then
without
if H is irrational,
h is irrational.
then F of H is 0.
That will be minus 1 by h if h is irrational.
So, yeah, the derivative obviously does not exist because we can find some irrational sequence which converges to 0,
Yes,
but
right?
this does not converge anywhere.
That is as h tends to 0 through h is irrational number, right? I mean, what you can just
Yes.
give is equal to, why don't you give is equal to square root 2 over n? Even then itself,
Yes.
it will be, it does not exist, right? So that's why f0 is equal to 0 now. If you take, then things will be difficult, right? So f0 equal to 0.
Yes.
Let's say f0 equal to 0. Then you cannot say from here, from this irrational number things,
Yes.
right?
Yes.
Then what do you do?
Then, if h is irrational, then the limit is 0.
Sorry?
But if it is rational, if h is irrational,
Yeah,
then the limit is 0.
exactly. Limit, you cannot say anything about that, right? So that will be 0.
Uh,
Right.
yes, but if h is rational,
Okay.
then let's say h is p over q, where GCD of p and q is 1 and q is a natural number.
No, no, no. 1 minute. Let's again tell me. F is H is rational number, right?
Yes.
H is rational. Okay. Now, what about this F H minus F0? F H over H. That will be again F H over H, right?
Yes.
Tell now. Tell.
Then h is p over q, where GCD of p and q is 1 and q is a natural number.
Yes.
So let h be p by q,
Let H be P by Q.
where GCD of p and q is 1 and q is a natural number.
Yeah, that is okay. That is okay. Everything is okay.
Then f of h is 1 by q.
F of H is 1 by Q.
So f of h by h is uh,
Equal to
1 by
uh,
q by p by q.
1 by P, right?
Yes.
Yeah. Then
Uh, wait, I'm trying to think.
yeah, you cannot always say that is conversing to 0, right? Even H converts to 0, P might not converse to 0. That may happen also.
Hmm. Can you give an example?
Yeah, this no with example maybe what you can do it here. Let's say 1 by n. If you take 1 by n, that will be much easier, I guess. 1 by n, which converts to 0, sequence of rational numbers, h equal to 1 by n. It can be because it converts to 0, right? Then what will be f of
Yes.
1 by n? F of
N.
1. No, f of 1 by n is 1 by n, right?
All right. Yes.
Yes. And f of 1 by n over 1 by n, sorry, 1 by n over h also 1 by n.
Yes. This converges to 1.
It converts to 1, whereas for the rational numbers, if you consider, that will be for h rational. This is h rational, and h
H
irrational.
irrational, it converges to 0.
Exactly. F is over h is equal to 0. I mean, or as h tends to 0, limit also as h tends to 0. That's a 0. So does not exist. So limit means f prime 0 does not exist. That's why, right?
Yes.
So yeah, so f0 is equal to 0 was that's thus the f0 equal to 0 is important. Otherwise, yeah,
Yes.
it will be much little more easier, right?
Yes.
Yeah, so some questions like this, where there are many questions where I forgot. If you have to check a few things, then only I will get to know whether. Okay, some questions I got. Let's say f from R to R differentiable function, hmm, right? Differentiable function
Yes.
at x is equal to c. Here c belongs to R. A set of anyway, f is from R to R, so don't need to worry. And f of c is equal to 0. Okay, and we define gx
Yes.
is equal to mod of fx. I mean modulus function, nothing but g is differentiable at x is equal to c if and only if f prime c is 0. Something very strong result you can see, maybe this how much the statement at least, maybe your proof will be easy or something, but the statement is good, right? So we have a function fx which is differentiable at c, and you know fc is equal to 0 also. And then if you define gx, or if you think about the function mod of fx, that will be differentiable at c if and only if f prime c is equal to 0.
I think I can do the backward implication, but forward implication is a bit hard.
Backward integration.
Yes, if f dash c is equal to 0, then
Okay.
I think
Average is equal to 0
it
then.
works.
Sorry.
Then g is differentiable.
Oh, that you could prove that.
Yes.
How? Okay, maybe you just took like this, f of g of x minus g. Is it? Or what you did? And that's what I want to
Yes.
know.
Yes, just the f of x plus h definition.
Yeah, or f of x, x tends to c, or f of x plus h, whatever is that. So c plus h. Let's
Absolute
say,
value of f of x plus.
right, like this, right?
Yes.
Sorry, this is mod. This is mod. Whole thing. That is nothing but. So what is fc? Fc is anyway 0 is given to you, right? So it is f of c plus h mod over h. Yeah, then
Yes, then we can multiply and divide by mod f of c plus h, assuming it is not 0.
multiply by,
If it is mod f of c plus h,
then it will be square and above will be less than, no, sorry. I don't know how, where it can, okay. F of c plus h here. What you do? I don't understand.
f square c plus h by h mod f of c plus h.
F of c plus h, okay. Right, like you were saying. H, then
Then we can, no, f of c plus h square by h mod f of c plus h.
okay, let's say no problem.
So mod x square is just x square.
Okay. Yes, f of c plus h whole square.
So write one f of c plus h as f of c plus h minus 0,
Okay, then
which is f of c.
f of c plus h minus 0, right? That's what you're telling. Over h you will be taking.
F of c,
Huh? Sorry, f of c, right?
yes. F
Yeah,
of
that's
c
the
over h times
time.
f of c plus h by mod f of c plus h.
True. F of c plus h over mod of f of c plus h. Then okay, yeah.
So
Yes,
this is f of c plus h by mod f of c plus h is either plus 1 or minus 1.
true. But you don't know whether that is bounded or not. Okay. Yeah, tell then.
Yes, but and the left product is just f dash c, which is 0.
If that is 0, then it will be defensible, right? That you can say, right?
Yes.
Only when it is equal to 0, right? I mean, you got everything because why it is has to be only 0? Like only if it is 0. If 0 is, that is okay. That will be, of course, g prime will exist. But why it has to be only 0? Otherwise, it is not. It will not be. From here itself, we can say. That's why I'm asking.
Right, right. Assuming it is non-zero, then
Exactly. If just
yes,
assume
that
something
plus
non-zero.
one and minus one will do something.
Exactly. Exactly. That will do something when it will. It may give you two different values, right? Which cannot be, right. For if c plus h, if it is
Yes,
greater than 0, it will give you plus 1. Otherwise, it may give you minus 1 also. So it has to be only
yes.
0. Otherwise, it can give you multi-valued, and that will not. That may that imply it does not exist. So that's all. That is the thing.
Yeah.
Yeah. So
Yes.
yeah. It has to be only zero. Otherwise, it will not be differentiable at means this limit will not exist. Differentiable limit will not exist.
Yes. Can you just give me 1 minute? I want to drink some water.
Sure, sure.
Yes, I'm back.
Okay, so let me find some other question. Yeah, one more type of question I got. Then maybe we can think of finishing. But yeah, that another type of question is much useful that I just I found. I thought by myself I just have to give the correct questions. Okay, yeah, I got it. Yes. So this one also I'll try. Okay, so the questions will be like this. It is easy, but the question is like this. Prove that between any two real roots of the equation to the power x sin x plus 1 equal to 0, there is at least one root. This type of question is done. I did know, right?
No.
Yeah. So equation tan x plus 1 equal to 0. So I'll tell you this. This is you use Rolle's theory. That's all. You have to use Rolle's theory. There is a hint. But try this. First, read the question, then you will understand. You will. It will be easy, but the thing is understanding this. So between any two real root of an equation, there will be one another root of this equation, another equation. But that you can do using Rolle's theory. So that is something good, right? So once you use that, you will understand the Rolle's theorem how it is strong.
But there is only tan x plus 1 or some e to the x is also there.
I don't think so. You try, you will understand.
Okay. Oh, I got it.
You got it?
Yes. The derivative of the function is e to the x sin x plus e to the x cos x.
Yeah, so that's why tan x will be coming and e to the x will get vanished, right? But these type of questions are, useful.
But what if cos x is equal to uh, 0?
Sorry?
But we have to divide right by cos x.
No, 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 no. You tell me cos x equal to 0. What do
The
you
derivative is e to the x sin x plus e to the x cos x. Right.
undo? Okay, let's. Yeah, e to the power x times sin x plus cos x equal to 0, right? Sin x plus
Yes.
cos x equal to 0. That's what you are getting. Now cos x is can be 0
Yes.
when x is equal to 2 pi 3 pi like that, right?
Right. Then sin x is equal to plus minus 1. So the equation won't satisfy. Right. I got it.
Even yeah, that root will not be there sin x plus 1, right? It was x sin x plus 1. That will not be also the root then. Okay, so another question I wanted to do, but I am not getting the place. Okay, forget this. Thank you for your attention. Before that, I do another question. Then only we will end this session. See, this time I had to do a prepone this class, right? So I did not prepare with a very good presentation type of thing. But from the next class, I will be doing that same. But for now, maybe for this class, forgive me. So this another question is x plus 1 by x, that is 1 plus x less than x.
I
So
have done this.
this is okay. You have done.
Yes. Yes.
Can you deduce from there this one? Can you deduce that?
Let me try.
Yeah.
I'm not able to start.
I am also thinking, just 1 minute. Few minutes you give me. I'm thinking about this also. How to do this. It will be easy, some good trick, okay? Nothing else. Problem is. Yes. First one. See, one I was thinking is like you have this x, right? Instead of x, you put 1 by n plus 1. Hmm?
Okay.
And 1 by n plus 2, 1 by n plus 3, and then you add them up. You will get this quantity, you will get hopefully, right?
Maybe.
Not maybe, just try that part. And I can tell you, right?
It's the middle quantity.
No, middle and I mean the less than part. This less than something. A is less than first part. You take x 1 plus 1 by n plus 1. The next 1 by 2. 1 by n plus 2. And like that. 1 by 2 and up to 1 by 2 and then add them all them up.
Okay.
Right? You understand this, right? So you got it, that one you got it, right? Log of 1 plus 1 by n plus 1. That is less than 1 by n plus 1, right? That implies log of
Yes.
n plus 2 by n plus 1. That will be less than 1 by n plus 1. Similarly, what you will have? Log of n plus 3 over n plus 2 will be less than 1 by n plus 2. If you add these two, what will happen? You will get n log a plus log b implies log of ab. When you multiply them, you will see n by 2 will get cancelled. And sorry, n plus 2 will get
Yes.
cancelled, right? So similarly, if you add like 1 by n plus 1, 1 by n plus 2, 1 by n plus 3, like that, all the way up to n to n, you will see this 2n plus 1 over by n plus 1 will remain. That's okay,
Yes.
right?
Yes.
So first part is that's why that is easy. But how do you show that that is less than log 2? That is I'm concerned about that. I was thinking about that only. Okay, log 2 means it is 1. Okay. So if you can show that 1 by n plus 1 less than log 2 over n, then you are done. Because 1 by n plus 1, even 1 by n plus k mainly, where k is n to 1, right? And if you then add them up, you will get n times log 2, n times log 2 over n, so that will be log 2, right?
Yes.
You understand what I'm thinking? So then, okay, I was thinking like this. So in n plus k times log 2 is greater than, then if it has to be, then it has to be greater than n, and n log 2 minus 1. Log 2 is plus k times log 2, that is greater than 0. So what is log 2? Log 2 is 0.693 or something like that, right? Hmm?
Yes.
So I mean then that is nothing but which is something less than, yeah, I mean k is always greater than n, right? K is greater than n. So this will be always greater than 0. I think it is like this, we can do it. So n times log 2
I
minus 1.
think I got it. Uh,
No, no, no,
I
no.
got another solution.
Like how? Like how? Yeah, tell. I'm not. I'm forgetting how to do that.
Like draw the 1 by x graph.
Yes. Yes.
So we can plot points n plus 1, n plus 2, so on up to n.
Yes. Let's say from n plus 1 you are starting here. Yeah. Then.
Then you
Okay. Okay. I
can,
understand. You will be taking
uh,
integration, right? So
yes,
integration. Yeah. So integration will be from n plus 1 to 2n.
n plus 2 you do, that will be greater.
N plus
2n plus 2. Sorry, n plus 1 to 2n plus 2.
n plus 1 to 2n plus 2. Okay. That
So I
integration.
think that will be lawful.
No, 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 no need to take. Yeah, yeah, I understand your thing. I'll just draw it. So 1 by x is integration 1 by x. Integration of 1 by x from. No, no, no. Yes, 1 minute, 1 minute. What I want to do? I want to do this as 1 by x. No, no, it is not coming like this. I thought it like 1 by n plus 1 will be 1 by x will be. What we have proved. Okay, okay, okay. So for x by 1 plus x, you have x by 1 plus x is less than uh, less than ln of 1 plus x, right? Yes, ln 1 plus x. That is there. That is already here. This first part, which you have
Yes.
proved, I did not do. So there, what we will do is 1 by n minus 1. 1 by n. If we put 1 by n, then it will be 1 by n plus 1 less than ln of 1 plus 1 by n, right?
Yes.
So if you put 1 by n plus 1 also, whatever you put, it will be 1 by n plus 2 again also will be ln of. Yeah, I need some more spaces. Okay, okay, okay. Sorry for this small space and all.
you'll do maybe right here. Okay, so what we have, ln of 1 plus x is less than, no, is greater than x by 1 plus x. Now put this measure. You have 1 by x, then you can make it ln x. This I am not reading now.
I think I got it.
Yeah. Then please tell.
1 by n by 1 plus 1 by n is less than ln of 1 plus 1 by n.
Exactly. That's what we here you can do it. So mainly 1 by n
So
plus 1 will be less than, yes. Then
so on, 1 by 2n is less than ln of 1 plus 1 by 2n minus 1.
True.
Just add these.
Yes. Then what will happen?
Then I think ln2 will come.
Ln, you will have n plus 1 by n times, you will have left n plus 2 by n plus 1, right? No. 2n over, oh yeah, great, yeah.
yes, I was afraid to this do this. I mean, I was not confident. Okay. So then you will get ln to itself, right? You just add it. Good. That's all right.
Yes.
Yeah, I mean 2n plus 1, always this one will get cancelled, this one. So 2n minus 1 will also get cancelled. N over 2n over n will remain. So just do that. So mainly you have to use that. That's why you deduce from that inequality. And
And this is even a bit more rigorous.
yeah, it's rigorous also. And the first inequality you have done, right? This is, I assume this is done. What I have done. I mean,
Yes.
yeah, that's easy, right? You just use fx as log of 1 plus x minus x over 1 plus x maybe, and you just take f. You see what is f prime x, that will be greater than 0, and then that's how you say that f prime x is greater than 0 means fx greater than f0 for all x greater than 0, and similarly you do the other one also, right? That's much more
Yes.
useful. Okay. I think if you have any other question you ask, otherwise we'll maybe try to end this session. There's no one else also there. And although my time is
I
less,
asked, I have
yes.
questions from other fields,
Other series. Sorry,
like algebra questions.
algebra. That's not here, right?
Yes.
Yeah, that we can do.
Yes,
I mean,
but if you
I,
can solve,
I can stop maybe here, this one. I mean, then we can do it. That is not a problem.
okay.
But yeah, we can recording. We can stop it because for this class we don't need, because this will be in putting. We'll be putting in the uh, YouTube, right? YouTube video, as a YouTube video. So
Yes.
yeah, so for
Right.
this lesson we can stop it. Maybe we'll do later some days, or today maybe some day we'll fix and we'll do it for that algebra. Algebra means which algebra
Okay.
you are talking about anyway?
Like simple problems, basic,
Basic what? Group
like
theory.
equivalence relation. And
Okay, that's not a problem. Okay, you can do it later someday, or today maybe. Today also, if you want. We'll stop recording for this session, then we will start that.